Hi guys, and welcome to today's video. In today's video we're gonna see the Cortex-M microprocessor SysTick Timer. We're gonna see the different functionality supported by this SysTick Timer, as well as how we can set up the different SysTick Timer registers to be able to measure the time and trigger SysTick Timer interrupt. And finally, we're gonna see some demo executing STM32 microcontroller. From functional point of view, the SysTick Timer is just a counter that consists of 24 bits. This counter will be decrementing based on some input clock. This input clock will be either the same CPU input clock source or coming from different external clock source. Initially, a reload value will be loaded into the counter to start decrementing basically from this initial value. This reload value is saved within the SysTick reload register. Now the counter will start decrementing starting from this reload value until it reaches 0. If it didn't reach yet 0, then it will go back to the same state and keep decrementing. If the counter reaches 0, then we'll go back to the initial point by loading again this reload value onto the counter, and the counter start decrementing again. Besides going back to the initial point, the SysTick Timer will generate an interrupt that will be forwarded to the Cortex-M microprocessor CPU. From programming point of view, the SysTick Timer has set of registers that allow, first of all, enabling and disabling this timer counter separately. This is part of this SysTick control register, as well as highlighting and firing basically a SysTick Timer interrupt once this counter reaches 0. This is as well part of the control register. Selecting basically the different input clock source to clock our counter, and highlighting basically if there has been a counter rollover or not via this flag bit. We have a separate and dedicated register to hold this initial reload value. Then we have the SysTick Timer counter itself, and finally we have a calibration register used to calibrate basically the tick to decrement our counter. So guys, this is our Keil MDK project, and as you can see, this is a C-based project that has been compiled for an ARM Cortex-M based platform. Our hardware consists of an STM32 microcontroller, and right now we have compiled and loaded the binary into the STM32 microcontroller flash memory. We have now initiated a Keil MDK debug session, and we will see within this example how we're gonna program the different register of the SysTick Timer to be able to decrement the SysTick Timer counter register, and finally how we'll be able to generate a SysTick Timer interrupt. Now let's move to our main function. First of all, to reprogram the SysTick Timer registers, we need to disable it. Hence I have written 0 into the control register. Then I need to make sure that the SysTick Timer counter register also is initiated or initialized to 0. Then I need to program again this load register with the initial reload value. If remember, once we start our timer, this reload value will be loaded into the counter register to start decrementing from that initial value. Then here I am programming again the control register. Here I am telling the SysTick Timer that you need to be enabled, so I am setting the bit number 0. Then I'm setting the bit number 1 to tell the SysTick Timer to generate an interrupt once this counter, let's say, register reaches 0 or roll over. And finally, I'm telling the SysTick to use the processor input clock source. So now the SysTick Timer will be clocked as same clock as our processor. Now, let's single step. So if we take a look into our SysTick Timer registers, as you can see here, we're gonna see that the reload register has been programmed with this value. Now, once we started our SysTick Timer, this reload value has been loaded into this SysTick Timer var register, which is our timer counter register. Now I have already selected the processor clock source to be our SysTick Timer clock source, as you can see, and also I told the SysTick to generate an interrupt once the counter register reach 0. Right now this flag register is reset because there has been no let's say SysTick Timer counter register rollover. Now let's set a breakpoint in our SysTick Timer interrupt handler, and then we can move, and here we go. We can see first of all that this count flag has been set to 1, obviously because our SysTick Timer counter register has reached 0. Once it reaches 0, it will be loaded again with this reload value, and this is why we don't see 0 here, because it has been loaded again with this value and then started decrementing again. Then the second side effect is that there's gonna be some interrupt line will be triggered, and the CPU will be able to catch the SysTick Timer interrupt. The SysTick Timer can be used, for instance, to measure the time for some software API calls. It can be used as well to preempt some thread or process, and this is quite suitable for a real-time operating system that are deployed in our microcontroller. Thank you.